Hi everyone, I'll be sharing my screen right now. Putting in a slideshow mode. Yeah. Uh, Welcome back to the session again. Hope everyone is doing good. Um, in the last session, we discussed about what are the disadvantages of physiological as well as the behavioral, and which is accurate, as well as we discussed a lot about what are the types of the traits, history of the biometrics, everything. Okay, I don't want to repeat that again. We had a proper revision in the previous sessions as well. So straight away, before moving into this session, we discussed in the previous session what is unimodal and what is multimodal. So these are the biometric system, how the biometric system is classified. They are classified into unimodal and the multimodal. And if it is a unimodal, we have to use a single trait. And if it is a multimodal, we'll be using a multiple trait. So in this, we are going to discuss on deep, as well as we discussed why there is a need of the multi-model. Okay, in this session, we are going to discuss deep about what is multi-model biometric system. You can look into this diagram. So multi-model means we will be using a multiple trait. So first trait I'm using here is the fingerprint. And second fingerprint I'm going to, sorry, second trait I'm going to use is an iris. Got it? So multiple traits I'm going to use. So automatically that refers to the multi-model. Then I have to make a feature extraction. What is feature extraction? So for the fingerprint, the extraction that will be made is a minute. And then I'm going to use a template, whether I'm going to use it for a single person or n person. So if it is a single person, it will be represented as 1:1. And if it is a n person, it will be represented as a 1:n. So according to that, it will be loaded into the database. And then depending upon the algorithm that we are using, okay, in the algorithm, we'll be declaring the match score. Okay, if it is above 80 or if it's above 70, it is represented as a matched. Okay, like that, the matching model will be done and the decision will be made whether it is accepted or rejected. For that, the 5 fusion strategies are available that we can discuss later. So similarly, for iris as well, we have to do. So again, the feature extraction should be done and matching module should be done. And according to that, the decision will be made. Okay. And then what you have to do is that we have to operate both the things. For example, I'll be giving on another example. So I'm having my ID. Okay. This is my ID. So in case if it is a multi-model, I have to place my ID in the biometric system. So automatically the system will recognize me. That will be my first authentication. And second one, I have to show my face for the certain distance. So for that, the methodology that will be used is the Vaila Jones detector that we can discuss in the further unit. So now I'm discussing just about according to the syllabus. I'm just discussing about just a unit one. Okay. So after that, what you have to do after recognize both the things only, the biometric system will identify the individual. You should not use either one. We have to apply both the things. Okay. So that's a most important concept in a multi-model. That's the reason why we are moving from uni-model to the multi-model. So that's an additional security. We cannot show our presence through a single one. In case if the problem, for example, if the iris is problem, automatic in case if my ID card cannot be recognized, automatically I can not the system cannot recognize my identity. So my ideas also should work as well as my face recognition also should work. That's what this arrow mark represents. After getting this input, I have to collect this input. Both will be enrolled and loaded into the database, and we have to come to the conclusion that is whether it's a verification or identification. Then we have to combine this, and according to that, it is accepted or rejected. We have to come to the conclusion. Okay, this MM represents the matching module and DM represents the decision module. Okay, this is for the first trait and this is for the second trait. So this is all about the diagram. Now we can move into the next slide. Okay, so multi-model biometric system, it's understood that merge two or more biometric technologies such as facial recognition, fingerprint, iris, scanning, hand geometry, voice recognition, etc. Okay, the system take the input from the single or multiple sensors for measuring two or more different biometric characteristics. That's what. This is what a multiple sensors, and it is collecting the multiple inputs. And what is the main advantage of it? By collecting the multiple inputs, it will improve the recognition rate. So, next, these are the integrated scenarios. So, first is the multiple sensors, and second will be the multiple biometrics, and third is the multiple units of the same biometrics, and fourth is the multiple snapshots of the same biometrics, and fifth is the multiple classifiers. So I'll be explaining through this diagram. So what is the multiple sensors? So if it is, what are the two types of the multiple sensors? So first is an optical sensors and second is the capacitance sensors. So optical sensor is the sensor that we use in an organization. I mean, fingerprint we'll be using in a biometric application that is posted on the wall. I mean, that is put on the wall of the in the any of the departments or something near to our staff rooms or something. If it is a capacitance sensors means the sensors that we use in our mobile phones. Okay, that is known as a multiple sensors. Second one, face and the fingerprint. What is face and fingerprint? That are the multiple traits. First is a face and second is the fingerprint. So that's what. This is the multiple biometrics. Okay, third one is the multiple units. So I'll be collecting the samples from first finger as well as the second fingers. But the input of both the things will be same. And multiple snapshots means what's the thing is that first I'll be collecting the input from this, and after some time I'll be collecting the input from the same finger again. Okay, what is a multiple matches means I'll be using the multiple algorithms. So first, if I'm taking a fingerprint, I'll be what the feature extraction will be done by using a minuty. For that, I'll be using a minuty algorithm. So this will be operated by using the ridges and the value. Okay. And second one is the another algorithm is known as the texture algorithm. So that will be collecting the input through the texture. What is the texture means? The shape of the finger. So these are the five things. First is the multiple sensors, and second is the multiple biometrics, and third is the multiple units, and fourth is the multiple snapshots, and fifth is the multiple matches. Okay, this is about the multiple algorithms. So multiple algorithms is the first algorithm is the texture algorithm, and second one will be the what is it? Minuty algorithm. Okay, always the accuracy rate will be higher for the minuty algorithm compared to the texture algorithm. So multiple instance biometric system means multiple sensors. I already said it is a capacitance sensors as well as the optical sensors. And what is a multiple sensorial biometric system? So system use two or more instantly different sensors to capture the same instance of the biometric system. That's what. I'll be collecting the input from one finger, and after some time, I'll be collecting the input from the another finger. So there are the various fusion strategies that are available. So that's what I said, right? There are 5 fusion strategies are available. First one is the sensor level fusion, and second is the feature level fusion. This will be for the fusion prior to the matching. And third one is the fusion after matching. In that one will be match score fusion, rank level fusion, and decision level fusion. So what is sensor level fusion? Simply, I'll be explaining. It's a very, very easy concept. What is a sensor level fusion means? So initially, I'll be taking a sample from one finger. Okay. And after some time, I'll be taking a sample from the another finger. Okay. And I'll be mosaicing that. Mosaicing means I'll be combining that. So the input area will be higher. So I have to apply the level of the region. So through that level of region, only the region which I'm going to consider, that will be considered as a true, and remaining things will be discarded. Okay. Then I'll be using the minuty algorithm. After applying the minuty algorithm, what I have to do is that I have to identify the score for it. So I already said if the score is more than 70, according to my algorithm, if the score is more than 70, then the decision will be made. Like whether it is true, if it is more than 70, the score will be the similarity score and it will be considered as a true. So through this slide itself, I explained everything. So sensor means I'm collecting the multiple samples and through that I'm combining both the things. Okay, I'm collecting the sample from the same finger and then I'm mosaicing it and I'm applying the minuity. Okay, so after applying the minuity and I'm checking out the score, whether it is matching or not. If it is matching, then it is a minuity. Sorry, yeah, similarity. If it is not matching, that is dissimilarity. So if it is matching, the rank level will be less. If it is not matching, the rank level will be very high. And accordingly, the decision will be made. So through the sensor level itself, I explained all this. So if it is a feature level, means slight difference will be there. The thing is that after taking the sample, we will be identifying the minute. I mean, we'll be making the feature extraction. How the feature extraction will be done? Through the minuity algorithm. After identifying the minuity for the two samples, then we'll be doing the mosaicing. Mosaicing means joining, and then we'll be identifying the score, whether that is matching or not. Then we'll be identifying the rank. If if it is a similarity score, the rank will be less. The similarity score is, if it is not similar, I mean, if it is dissimilar, the rank will be very high. Then accordingly, the decision will be made. Okay. So what are the topics basically we discussed here is that we discussed deep about the multi-model. Okay. In the multi-model, we discussed about the 5 things. We discussed about the multiple sensors. We discussed about the multiple biometrics. We discussed about the multiple units. And we discussed about the multiple snapshots as well as the multiple matches. And before that, we discussed deep about this diagram. So we have to collect the input from one trade as well as we have to collect the input from the another trade. And we have to combine that. Then only we have to come to the conclusion. We cannot come to the conclusion by using a single trade. If we come to the conclusion, that is not a multi-model, that is uni-model. My main objective is that I have to use a multi-model, not a uni-model. Okay. And then we discussed deep about what are the various fusion strategies. First is the sensor level fusion, and second is the feature level fusion, and then third is the match score fusion, and rank level fusion, and decision level fusion. So according to the exam point of view, this different fusion strategy is very, very important question. You can make a note of it. Those who are viewing my video in the platform. So this is what they explained in this various fusion strategies. Okay, what are the advantages of the multi-model biometric system? And what are the biometric system errors? And what are the performance measures? These are the 3 topics that I'll be making as a short video and we can discuss in the next session. Now I'll be stop sharing. Thank you.